Hello and welcome to section 2 of our NLP course, Text Preprocessing Essentials. Before we train any machine learning model, before we dive into fancy transformers or deep learning, we need to clean our data. Why? Because remember this famous quote in data world and data science, and that is garbage in is garbage out. What it essentially means is whatever you put into any algorithm, you are going to get the same exact thing. So if you put in garbage, you will get the garbage out. So we need to be mindful of this fact that we need to take this process very seriously. That is the process of text pre-processing. Okay, so let's dive in. So first lecture is introduction to text pre-processing. Okay, so now before I go forward and start doing hands-on in Python and using NLTK, I would like to spend some time on uh, talking about some of the fundamentals. And before even we do that, I would like to give you this example, which is example of a sample tweet done by maybe somebody who has purchased your goods. So now consider this particular tweet where we have lots of words, lots of punctuation, and we have this, we have is, the. Now consider the same exact tweet, but after the text pre-processing steps have been completed. In the second tweet, as you can see, you won't be able to see those redundant words, these emojis. Only keywords are mentioned, which is product, real, worst, never, again. And it is what we precisely do in text pre-processing, right? So this particular example captures the essence of what text pre-processing is all about. Okay, all right. So if your input text is messy, inconsistent, or poorly structured, your models won't perform well, no matter how complex they are. Okay, so you need to make sure that you understand text pre-processing, and you need to make sure that before going forward with any modeling using NLTK, you understand this particular step. So what we are talking about here is cleaning text would imply clear results. So cleaning text improves model results greatly. Okay, text pre-processing builds understanding between humans and machines. Okay, now what we are talking about here in the second point is that machines have a different way of understanding and interpreting text. Okay, so that is why we need to make sure that machines understand the text clearly, and hence we have the step of text pre-processing. All right, so we will cover various steps like tokenization, stopword removal, stemming, and lemmatization in this entire section. And yeah, as it is written here, messy text input leads to unreliable model. Okay, so we are going to be looking at various steps which are involved in the text pre-processing. So let's dive in and start with the first step, and that is tokenization. Okay, I am assuming that you have got Python installed on your system. If not, what you need to do is you need to go to the Python's official website, python.org, and install the 3.12 version, because any version which is greater than 3.12, currently NLTK is not supporting versions greater than 3.12. So make sure you have a Python installed, and once you have that, what you need to do is you need to open command prompt and do pip install NLTK, and it should install NLTK. And since I have already got it installed, um, it's done. Okay, so see you in the next lecture where we are going to be talking about tokenization. Thank you so much. Welcome to tokenization. Tokenization is a process of breaking a large chunk of text into smaller pieces. Now, those smaller pieces are essentially what we call as tokens. These can be sentences, words, or even subwords. Let's start with an example. What I would like to do is I would like to take you to the actual Jupyter notebook where I'll demo how we can do the tokenization process using NLTK. Okay, so let's get started. So what I'll do is in the in-video practice, I'll open the Jupyter notebook and I'll create a new notebook here. And within that notebook, I'll be demonstrating how we can understand and create tokens of our text. So let's rename this notebook as tokenization. So before doing tokenization, I need to import the NLTK package. And I hope that you must have followed the instructions given in the lecture section 1, sorry, where I walked you through the process of downloading Python and downloading NLTK. So let's import this package. And once this has been imported, what we will do is we will start importing the necessary modules, or we can also not import modules directly. So there are two methods actually. Okay, so we can either do from NLTK import word tokenize. So we can import tokenization functionality like this. Okay, so or we can combine this like this using this cool little feature of Python, wherein we can import two different functionalities simultaneously. So we can do that. And there is one more method where we can import from tokenize module these two. So you see this, all of these are same. All both of these import methods are same. Either we can import using the submodule tokenize, or we can import from the module uh, main module NLTK. Okay, or we could have just uh, use these functions as NLTK dot word tokenize. In that scenario, we did not need to import these two functionalities. Okay, so let's come to the main lecture, and that is to tokenize. So let me define a text. So I'll create a text which is hello, how are you doing. Okay, this is a simple text. And if we take this text and we do something like word tokenize and pass text into this, you see this, it has splitted this entire text into smaller pieces, and these smaller pieces are words and also punctuation, right? So now, why does punctuation matter? See, it depends on context to context. In some cases where, let's say, our intention is to understand the sentiment of text, punctuation might not matter that much. But in some other situations where we need to understand the context of the entire text, entire document more clearly, in that scenario, we might need to understand and you know um, take into account punctuations. So by default, word tokenize splits the entire text into words and punctuations. So in further downstream processing, we might need to take care of that as well, right? So now let me show you one example. Let me write down one text, which is, let me write down one comment, which is don't do this. Okay, so this is one comment, and then another comment is do this. Okay, now if you think about it, removing punctuation blindly, so if I, let's say, remove this and this, might have a serious impact differentiating between these two sentences. So you get this idea that we need to make sure that punctuations are there in some situations, while in another situations they can be omitted. Okay, now there there is one more kind of tokenization provided by our NLTK package, and that is sentence tokenize. Let me define a corpus. Now, corpus is a word in NLTK or in natural language processing, which means a collection of text. Okay, so a collection of documents is also called as corpus. So now, in corpus we can have multiple sentences or big text. So maybe he is a nice boy. How are you doing? So we see that there are two sentences. Now if I have to, okay, so I need to close it. If I have to tokenize it this into a sentence, so I can do something like sentence tokenize and corpus. So it gives us a list of two sentences. Okay, all right. So now what you can do at this point is you can pause the video and you can maybe try tokenizing on your own. Maybe let's write an imaginary tweet that is just saw the movie. Maybe I don't know, Iron Man 3. It's epic. Okay, maybe some exclamation mark. So this is a task for you, that maybe tokenize this. Okay, tokenize this. And by the way, I'll be sharing all these notebooks, so you don't have to worry about this. So all these assets are you can find it in the description or maybe in the resource section of the course. Okay, so now I would like to stop right here or maybe go back to the slide that I had. So essentially tokenization breaks text into smaller parts like words. Machines uses tokenization to understand text data. Punctuation significantly impact how text is tokenized, as we discussed. Different languages need specific tokenization rule, and by the way, NLTK handles different languages very gracefully. You just need to download the appropriate packages and appropriate corpuses from NLTK. Rest is taken care by NLTK. Okay, so now let's move to cleaning out the noise and start with stopwords. Thank you so much. Let's talk about stopwords now. Stopwords are words that are commonly used but add little meaning in many NLP tasks. Notice yourself, notice myself. In my language, most of the words that I am using are meaningless. For example, is, the, at, on, but. Some have meaning, but they are essentially stop words, meaning they are used to stop a sentence or sentence. They are used too frequently that it does not add much meaning, but adds noise to our sentences. So for our task, it might not be important. But caution: if you are working on a sentiment analysis project, removing words like, say for example, not could flip the meaning. Okay, let me give you one example. If I open Notepad, if let's say I put out a review for a product, like I like the product, I liked the product, or maybe I loved it, or I did not love it. Okay, you see, if I, while pre-processing, if I remove the not, then my pre-processing pipeline would consider this whole sentence without not, and it might mislead my calculations. Okay, so uh, removing stop words can reduce some noise effectively, but it has to be done in a intelligent manner. Be careful removing stop words for sentiment analysis. Stop word list may vary across different languages, but here again NLTK would help you in our case, I'll be giving you a demonstration using English, but the same can be followed for different languages. Okay, compare tokens before and after stopword removal. Okay, we will be doing that. Okay, so what I'll do is I'll go to Jupyter Notebook as before, and I'll create a new notebook. And in this notebook, I'll call this notebook as stopwords removal, or maybe just stopwords would do the job. Now I have to install. I have to basically get two packages, or maybe I might need to download English stopwords. But first, let me import word tokenize and stopwords. So I'll say from nltk.corpus import stopwords. Okay, all right. Now from nltk.tokenize import word tokenize. Okay, so I have these two sorted out. Now what I need to do is I need to define a sample text that I'll be working with. So I'll say NLP, maybe create a sample sentence, and as NLP is the future of AI. Okay, something like this. Okay, so let's first of all get words from this. Okay, I'll do maybe word tokenize and pass out this entire text, and after this I'll print out the words. So we see this NLP is the future of AI. We clearly see that is the and of are stop words. Now how do we get rid of these from our tokenized words? What we can do is we can say stop words dot words. So this is a function in NLTK where we can pass things like English, Russian, and it will provide you the provide all the stop words. Now how can you use it? I can create a list called stop words, but notice here sometimes, and it this particular error has been done by me also. Notice the naming convention of this and this. If you name it like this stop words, then you won't be able to access it here. So please remember this. Now I have stop words list, or maybe stop words set. Now what I can do is I can create a loop to get a filtered words. So I'll say words is equal to, or maybe I should rename it. Okay, filtered words, and I'll create a maybe list comprehension. I'll say for word in words, if word not in stop words. Okay, then I'll put it in word, otherwise no. And if I now print filtered words, we see that we only see NLP, future, and AI. I think it would have been better if I had done word dot lower, although here the result would be same because it's not a big text, but in bigger corpus, in bigger documents of size, let's say many books or maybe newspaper, this would make a difference. Okay, all right, so we have got this filtered words. So now what you can do at this point? What you can do is you can take any product review and compare token with stop words and without stop words. Okay, but remember, usually with products review we don't want to get rid of too many stop words. So stop words removal can be done in a strict manner or in a easy manner. We have to go is easy on a sentiment analysis kind of project. Okay, okay, so now next let's learn how to simplify word forms, and that is through stemming. Thank you. Okay, so let's start discussing stemming. Stemming reduces words to their root forms. What do we mean by that? When we say root forms, every word has a root form. For example, runner and ran and running. All of these are coming from the same root word, and that is run. So run essentially is a root word for running, ran, and runner. Okay, so if I have a text which uses lot of these words, it would be intelligent to just replace them with run, because all of them are essentially using the same kind of you can say same base form, same root form, right? But it has a downside. Sometimes it does stemming very, you know, strictly, and it might result in some strange results. And there is one alternative to stemming, which is lemmatization, which we will be discussing in the next lecture. But for now, let's talk about uh, stemmer, and in particular I'll be talking about Porter stemmer in NLTK. So let's quickly show you one simple walkthrough of Porter stemmer. Okay, Porter stemmer. So what I'll do is I'll quickly from NLTK dot stem import the Porter stemmer. Okay, and once we have this imported, what we need to do is we need to instantiate a stem class. We basically need to create an instance of Porter stemmer. Now we have this stem class. What we can do is we can do stem dot stem. So this stem has a function called stem, and we can call this on running, and let's see what we get. So we get a run. Now let me uh, run it for ran. Okay, we get ran. Now let me do it for runner. We get runner. Okay, so now let's try to do it for maybe, I don't know, 1 second. Maybe I'll do stem dot stem on fly. Okay, you see flee. This is a downside. So if I so you see this fly and flies, both are stemmed to flee, which might not be a desirable thing in your project. And also nowadays, in old days, stemming was introduced to kind of reduce the amount of data storage that we have to basically store only the relevant words which we have to store to understand the context. But nowadays, with the power of computer, we usually don't have that issue. So that's why we don't do stemming that much, although it might come in handy for some of your projects. Okay, use it when speed is more important than precision, like quick text search or topic modeling or something like that. Okay. Okay, now let's explore a more intelligent alternative of stemming, which is lemmatization. See you in the next lecture. Okay, so let's talk about lemmatization. Lemmatization is usually considered as a better alternative to stemming, sorry, because it lets you provide and give you a context. And when I say context, what we mean is the word that you are about to stem or lemmatize, you can provide a POS tag or maybe parts of a speech tag for that while doing the lemmatization. So lemmatization uses the context to find the root word. It is usually more accurate, but then with accuracy also come the slower. So it's slow. Stemming, on the other hand, is fast because stemming works by storing the dictionary. We will learn when to prefer lemmatization. Lemmatization is usually preferred when speed is not an issue for us. Let's see lemmatization in action. Now, to be able to use lemmatization, you will have to download WordNet. So, one second, let me enable word lemmatization. So, what I can do is I can do NLTK and then NLTK.download, and I need to download the WordNet. And if I hit run, it should download. It is saying package WordNet is already up to date, which means I have already downloaded it. Okay, so now what I'll do is I'll import nltk.stem import WordNet lemmatizer. Okay, now I'll create a instance of it. Now let me tell you what did I mean by when I said context. So let me pass better. If I just run it like this, it is only giving me better, right? But now I can give it some context. I want a adjective. Okay, so if I run it now, it's saying good. Okay, so now let me run it with runner and pass the adjective as v, which is verb, and it is giving is returning as runner. But now if I pass a, again it's giving the runner, because a runner is the adjective. But in the running it's giving this, but with the verb it will give run, which essentially means it is letting you pass more contextual information regarding the kind of token you are dealing with. You are dealing with verb, adjective, or some other form of parts of speech. Okay, so in this lecture we have talked about lemmatization and how to do it in NLTK package. Up next, text normalization using lower casing and regex. See you then. Okay, so now let's normalize text. First of all, let's briefly talk about what normalization is. Normalization essentially means to normalize your entire corpus to follow a certain pattern, to be consistent across the entire corpus. And it involves a fixed and distinct number of steps, such as lowercasing. You want to lowercase your text first, and then you want to do some set of steps such as punctuation removal, emojis removal, number removal. See, this can be important in your project, but usually the kind of projects, most of the projects we deal with in NLP, we do this step of normalization, and it helps in further steps and further modeling steps that we will be learning later. Okay, so let's see how do we do the normalization. And for normalization, use of NLTK is often not required. We can do normalization even without the use of NLTK. So I'll quickly define a text which is, hey there, maybe add some punctuation. I am, or maybe I am learning NLP, maybe at the rate, add, throw in some of these. Okay, so we have this random text. Okay, now let's try to normalize it. So usually in normalization, the first step that we do is step 1, which is lowercase. And what I do is I'll define text lower, and there is this function called text.lower. And what this will do is it will simply take your text and it will apply the lowercase function, and it will convert, as the name suggests, it will convert it into lowercase format. Now there are many methods to get rid of punctuation and emojis, but the method which we all love is the method of regular expression. It offers a consistent way to identify all the non-word characters. So let me show you what I mean by that. So what I'll do is I'll find, so I'll apply this function called find all, and what find all will do is it will find all the strings or all the characters which follows the pattern that I specify here. Let me pass the text lower here. So let me pass h, and if I do this, it has found 2h, and let me count. 1h is here and 1h is here. It seems reasonable, right? But now I want it to find maybe, I don't know, maybe e. Okay, all right, we can see 4 e's. Now the power of regular expression lies in how we can ask it to find maybe word w, which means I am asking it to return all the letters, all the characters which are not punctuation. So it is returning all the characters except punctuation. So it has gotten rid of all the punctuation. Okay, so once we know this, and there are multiple ways to do this. I could have done maybe like this. I could have used a set operator, a to z, 0 to 9. See, it is still returning this. Now how can I use regular expression to kind of get rid of all the punctuation from this text and give me the text? One way is to simply join this, but I would not be able to understand from on where, like what I mean is, let me take this and let me try to join it. Okay, what will happen is something strange. So I'm not able to identify because I don't want to get rid of space, right? Space, although space is also punctuation, but I do want space. I want to get rid of these unnecessary punctuation. So how can I do that? There is a function in regular expression package which is np.substitute, and in this substitute we can specify the pattern just like this, and we can also specify what exactly I want it to substitute with. Okay, I want to substitute it with empty string, and I can pass the text lower. Now something very surprising is going to happen. Let me run it. Okay, so you see this, it has given me a text returning only the punctuation, nothing else. So how can I fix it? What I can do is I want it to replace all the words which are punctuation. Currently it is only replacing all the words which are not punctuation. So now if I replace this, I'm getting this. Now what is this happening? How can I make sure it does not remove this? So for that I can add a spacing, which means, so this is a special keyword which tells Python that don't remove spaces. Now see this, it has gotten rid of all the punctuation except for the spaces. Now what are these for backward slashes and w? These are so-called spatial patterns. Okay, so for example, this spatial pattern is known as uh, all characters except punctuation. Okay, punctuation and spaces, and this is all the white space characters. Okay, so now what we have is this text is a cleaned text. Okay, I hope this makes sense. And using normalization before tokenization and after, it depends upon your pipeline and your use case. Okay, now in the next lecture, whatever we have learned so far, like stemming, stopwords removal, all those things, what we will do is we will create a pipeline, a function where we can throw one text and it will return a cleaned text which we can use for the further tasks. Okay, so I'll see you in not Sue, sorry. I'll see you in the next lecture, and let's combine everything in the next lecture and create a pipeline. Okay, so in this video, we are going to take everything that we have learned so far in this whole section and create a function which will serve as a pipeline for text pre-processing tasks. So let's do that, and I'll name this notebook as text pre-processing pipeline. And when I say pipeline, what I'm going to do is I'm going to create a function which will be known as pre-process, and it will take raw text and it will return clean text. And our job is to create this clean text logic for clean text functionality. Okay, now there are some couple of helper function I would like to import as we have learned so far, which is first of all word tokenize. Okay, then from NLTK dot stem import wordnet lemmatizer. Then another function, so we have stop words, right? Corpus import stop words. Okay, so we have these functions ready, and let's also import maybe the regular expression package. Okay, so the first step would be of this pipeline is to lowercase text. So lowercase text would be raw text dot lower. Step 2 would be maybe remove punctuation, and without wasting our time, what I'm going to do is I'm going to open the normalization notebook that we had earlier, and we can get this function here. So cleaned new, maybe punctuation remove tag, or maybe clean text. I can say clean text is equal to, and I'll replace this with lower text. Okay, so now next step would be to remove stop words. Step 3, remove, okay, I misspelled punctuation, although it does not matter, you understand it, right? Okay, so to be able to do that, let's first of all load stop words as we learned in the previous lecture. I'll create set stop words dot words, and I'll do English. Okay, stop words. Now I would like to do filtered text word for word. Okay, I think before step 3, I guess we need to do one more step, which is tokenization. Tokenize. Okay, so tokens will be for, or I would say word tokenize clean text. Okay, so for word in tokens if word not in stop words. Okay, so it will give us the maybe filtered tokens, I would say. And finally I would say okay, this would be step 4, and step 5 would be lemmatization maybe. For that we need to define the lemmatizer wordnet. Okay, and I need to lemmatized tokens for word in filtered tokens. I'll say lemmatizer dot lemmatize and pass the words. So finally we have these lemmatized tokens, and finally what I can do is I can just join these. See, at this point we can either return lemmatized tokens or join these. It does not matter that much. Okay, now let's test our pipeline whether we are doing it right or not, and this time I'm going to test with real text. So I'll go to Wikipedia, and I'll grab some maybe some real text, maybe text on Donald Trump. I don't know, let's see. I'll grab this paragraph, Donald Trump, and yes, so we have this text on Donald Trump, Wikipedia. Let's test out our pipeline. Okay, it's taking some time, and the reason it is taking some time is because of lemmatization. Let me show you something without lemmatization, how much time it takes. Okay, let's comment out lemmatization. 1 second. So I'll just, or maybe I'll copy this entire function again, and I'll get rid of this, and I'll just use filtered tokens this time, and let's reload this. And this time, see, this was really quick. And lemmatization uh, has that is not having that much effect on it. Okay, all right, so this is it. This is our entire pipeline function which we are going to be using multiple times throughout this lecture. Let's now discuss what not to do when pre-processing. I'll see you in the next lecture. Okay, so welcome to this last lecture in the section 2, pre-processing in NLP. So in this particular lecture, I'll be talking about some of the pre-processing pitfalls that you should avoid getting into. The first pitfall is over cleaning, which means text can remove essential meaning. And one example we already saw in one of our lecture where I mentioned in the in the use case of sentiment analysis, you might, by doing stopword removal, you might remove the essential meaning from the text. So you have to be aware of this particular pitfall. Okay, and also the pitfall of overstemming, as we saw an example of in the stemming lecture, and in that we passed fly and it did flee, which means it overstemmed the token. Okay, and sometimes also regex can break text unintentionally. Okay, and it happens a lot of time when you don't understand regex, so you have to be mindful of this also. All right, aggressive stemming can distort intended meanings. Avoid over cleaning and consider your specific use case. This is very important. You need to understand the problem that you are solving for in the NLP. Okay, so yeah, uh, I think before closing off this lecture, I would like to just ask you guys that can you think of a case where removing stop words hurt your performance? I think I would like to know your opinions in the maybe discussion forum or maybe messages. Okay. Yeah, so now that we have ended this section, I would like to invite you to take a quiz and take the assignment that I have for you. Okay. Thank you so much. See you in the next section.